Hello, my name is Jonathan. I've been involved in quantitative analytics for 8 years, and I've been an ardent consumer of GPUs for 6 years. Today, I want to talk to you about why you should use GPUs over CPUs, not just for model training, but for your entire end-to-end data science workflow, including ETL and data processing. So, why use GPUs over CPUs? Well, the short answer is that they're fast, but not just fast, they're way faster. To give you an example, a top-of-the-line CPU will have 128 cores, each running at 4 gigahertz a second, and cost around $5,000. The RTX 3070, the mid-range GPU, has 5,888 cores, each running at 1.5 gigahertz a second, and costs around $1,000. So for 1/5 of the cost, you're getting over 10 times the raw compute power with a GPU. So before moving on, let's quickly review the data science workflow. We start off with data wrangling, processing, ETL, then we get into model training, and last we perform model validation. Now, in terms of GPU acceleration, the concentration tends to be in the model training and validation steps of the workflow. And furthermore, that concentration tends to be in the deep learning and neural network subfields. This isn't necessarily a bad thing, but it would be nice to be able to use the GPU for non-deep learning tasks. So if we look at a typical day for a data scientist using the GPU, it kind of looks like this. So we prepare our ETL pipeline here, and then we run our ETL workload. We realize that we forgot something, we run into issues, we adjust our pipeline, we start it again, we find some unexpected problems with our ETL, we fix our code, and we restart again. And this step is repeated multiple times throughout the day. It's not uncommon in the life of data scientists, but look at how much time is dedicated to just waiting for ETL to run. So some points of frustration include this. Very little of my time is spent doing actual modeling. Modeling is the easy part. Nearly all of my time is spent wrestling with my data and trying to beat it into submission. Another point of frustration is this. Some languages like R have inherent multiprocessing. Python, by purposeful design and good reason, is locked to using a single core. Now I can get around this by using the multiprocessing library, but it's still an extra step I have to take. This is also really frustrating. Pandas is a library with notoriously slow read, write, and aggregation speeds. The most popular data manipulation library for data scientists is super slow. And because it's Python, it can only use one CPU core at a time. Luckily, there's this wonderful unified solution. Rapids is a suite of GPU accelerated libraries for Python. And here are some of the more popular libraries. Today, we'll be working with the first two, QDF and QML. Also note that XGBoost, Dask, and Spark all have implementations that use the Rapids engine under the hood. Now, we found these gorgeous graphs online that showed some serious non-trivial speed improvements when using the GPU. I mean, we're talking orders of magnitude faster. So we had to test it out ourselves. We gathered a data set containing 20 million rows and 10 columns and performed a series of identical ETL processes for model training to compare CPU and GPU performance. And we found that, first of all, the entire process took about 30 minutes to run on the CPU. But more importantly, in the time that it took to simply read and write the data using the CPU, which was about 1 minute, the GPU was able to load the data, write the data, describe the data and set an index, concatenate and aggregate and encode the data, split the data, perform an OLS regression, logistic regression, k-means clustering, random forest classification, and gradient boosting classification. So the GPU was able to complete the entire workflow before the CPU was able to read and write the data. And we tried this across different file sizes too. So for this ETL process, we saw greater than 85% reduction in time. For model training, it was more than 98%. And overall, the entire process is 95% faster. So this means that an 8-hour workflow now becomes 20 minutes. If something took you an hour to run, it would take you 3 minutes. So the speed gains are astounding. What does this mean for my day? Well, it looks something like this. It starts off the same. explore my data set, setting up my ETL process, and then I go ahead and run my pipeline. But because it finishes up so quickly, I realize my mistake. I go back, fix my code, restart my pipeline. It finishes, I find some unexpected values. No big deal, I adjust my code, run the pipeline again. And by noon, I've actually finished transforming my data. So now I can get into actual model training, validation, and testing. And since the models also run on GPU, that finishes very quickly, and I can go through multiple iterations of this throughout the day. So by the time I'm done, I have a working, finished, optimized model, and I get to go home on time, which is nice. If we compare this to a CPU day, you can very clearly see the difference, shown in green here, between the ETL times and how much more gets accomplished by using the GPU end to end. I've basically tripled my productivity. Now, in addition to decreasing end-to-end computation time by 95%, decreasing, excuse me, by using the GPU, we can further reduce computation time by leveraging RunAI state-of-the-art scheduler and fractional GPU capabilities. By fractionalizing the GPUs, we can create little mini GPUs, and then we can use the RunAI scheduler to send an ETL job with a segment of data to each fraction. And the net effect is a sort of meta-parallelized workflow that is essentially GPU multiprocessing. Now, very quickly, I want to go over some questions I often get. All of my code is already in pandas. Do I have to convert it all? That's a great question, but because QDF and QML were specifically designed and look and feel like pandas in scikit-learn, nearly all of your code will be the same. So in fact, if you look at the notebooks on the GitHub, you'll find two differences in the notebooks. The first cell where we import the package, and even then it's only a slight change to some of the words. And the last cell where I have to pass it an extra parameter to XGBoost that explicitly tells it to use the GPU. Besides those two things, the code is identical. What if there's something I have to use pandas for? That's okay. Converting between a QDF data frame and pandas data frame is very easy. Both functions are a single line. You can switch to pandas, perform your computation, and then switch back to QDF. What if my data is too large for GPU memory? Not a problem. Rapids is well integrated with Dask. Dask is a framework designed to handle large data sets in a distributed way, and it was also designed to mirror pandas. If you're used to using Spark, Spark has also incorporated the Rapids AI engine in order to leverage GPU power. GPU instances are expensive. Isn't it cheaper to run my workload on a CPU cluster? Actually, that's not the case. This is directly from the Spark website. They ran an ETL experiment on a very large data set on CPU and GPU clusters. But because the GPU workload finished so much sooner, the total cost ended up being less for the GPU cluster than the CPU. In this case, about half as much. So to sum up, use GPUs. Thank you for listening, and until next time.